Hello friends, I, BHATIA, welcome you to my YouTube channel Maths DNA from origin to infinity. Before we begin, let me share something with you. We believe that to qualify 4 different examinations, all you need is just one single book, that is all-in-one book with 2000 plus solved questions. For this you can register on our WhatsApp number given below. Now, moving on to our lecture, it is the first lecture on linear algebra with the topic binary operation and its examples. This can be useful for many different competitive exams as well as for learning linear algebra from beginning. Let us begin. First of all, we will go through the definition of the binary operation. Basically, binary operation is a map. Now let us go through the definition first. Let A be a non-empty set. Underline the word non-empty over here. It has to be a non-empty set. Then a function f from A cross A to A, where A cross A denotes the domain and A denotes the codomain. Defines a binary operation on A, and we adopt a symbol, say star, to denote f of AB equals to A star B. That is nothing but the image of AB under the given function. If f of AB equals to C, we write A star B equals to C, where C is called the product of this binary operation between A and B in this order, means A is first and then B is second. See, the things to be noted down over here are, we can define a binary operation from a single set by taking the cross product of the set with itself and then defining the elements of the cross product from the set to the set itself. Also, we need to note down something over here, that A comma B, that is A star B, need not be equals to B comma A, that is B star A. They can be equal and they can be different also. Now let us go through some examples to understand it more clearly. The first one, let A be equals to n, the set of natural numbers, and A star B equals to LCM of A and B. So definitely it will be a binary operation. As for any two natural numbers, the LCM will again be a natural number, and thus our function will be defined and satisfied from n cross n to n, because the answer of the LCM will again be a natural number. Similarly, we can take GCD. Take A equals to n, the set of natural numbers, and A star B equals to GCD of A and B. Then again it will be a binary operation for any two natural numbers, because GCD of any two natural number will again be a natural number. So f will be satisfied from n cross n to n itself. These are the two common examples that satisfies the binary operation. Now let us see some example which does not satisfy the binary operation. Take A equals to the set of natural numbers, and A star B is defined as at least 2 less than minimum of A and B. Let me give you an example to solve this. It will not be a binary operation. How? Consider f of 1 2. F of 1 2 will be equals to minimum of 1 and 2 minus 2. Now minimum of 1 and 2 will be 1, and minus 2 will be equals to minus 1, which does not belongs to n. So the element that is resulting after applying the binary operation does not belongs to the set n from where it is taken. So it does not satisfy f of n cross n to n. So it is not a binary operation. I repeat, why it is not a binary operation? Because minus 1, the result that is appearing after the applying of binary operation, does not belongs to n, whereas n was our set. Now fourth one, take A equals to n and A star B equals to A raised to B. You can pause the video wherever you want, solve the examples first by yourself and then go through the solutions. Now this will be a binary operation, because if we take power of any natural number to another natural number, it will give you a natural number again. So it will be satisfied. Moving on to few more examples. The fifth one. Take A equals to Pn, that is power set of n, that is nothing but set of all the subsets of n, and define A star B equals to x union y, where x and y are the subsets of A. Clearly this will be a binary operation because two subsets union will again give you a subset of the natural numbers power set. So it satisfies f from Pn cross Pn to P of n. Similarly, we can go for the intersection. A equals to power set of n, that is set of all the subset of natural numbers, and A star B is defined as x intersection y, and x and y are subsets of A. Basically they are subsets of power set of n, and it will again give you a common subset that will be present in P of n, that will be A. So again f is satisfied. See, it is not necessary that the elements are only numbers. The elements can be subsets also, as you show here. Now the seventh example. Take A equals to z, the set of integers, and A star B equals to at least 1 less than A plus B. This is my favorite example. A star B is defined as at least 1 less than A plus B. See, here the word at least plays very important role because it will not be a binary operation. And now see how. Take f of 1 2, that will be equals to 1 plus 2 minus 1, because they are saying that A star B is at least 1 less than A plus B. So A is 1, B is 2, 1 plus 2, and 1 less than that will give you answer 2. But they have not said it is exactly 1 less than. So if we can take at least 1 less, we can also take 2. So f of 1 2 can also be equals to 1 plus 2 minus 2, and that will be equals to 1. Now here the function is not defined properly. It fails to be a map itself because it does not have a unique image. See, in the beginning of the definition I mentioned, binary operation is basically a map, a function. So if it fails to be a map, or if it fails to be a function, it cannot be a binary operation. So be very precise when you are dealing with it, that first of all, if you find any doubt of it being a function, then leave it over there, because if it cannot be a function, it cannot be a binary operation. Moving on to the next one. A equals to again the set of integers, and A star B equals to at most 1 more than A plus B. The same example can be used, but now they are saying at most 1 more. Again, it will not be a binary operation because we can take f of 1 2 equals to 1 plus 2 plus 1, that will be equals to 4, and also we can take f of 1 2 as 1 plus 2 plus 0, and that will be equals to 3. So we have two different images for one single value, and that does not define a map, and hence it is not a binary operation as well. Moving on to the the ninth one. A equals to r plus the set of positive real numbers, and A star B is defined as a raised to log b to the base e. This will be a binary operation because the base, that is A, is a positive number, and all the powers, that is log b, are defined for all the positive values of r. If A was given to us as real numbers, then this will not be a binary operation because log of negative numbers is not defined. But here the elements or the numbers are r plus positive real numbers. So log b will be defined for all the values, and thus A raised to any number will be again a real positive number. Yes, it can be 1 upon A, it can be inverse, but still it will be a positive real number, because if we take b as 1 upon e, then it will give you a raised to minus 1, but still a raised to minus 1 will be 1 upon a, and that will again be a real positive number. So hence it is a binary operation from r plus cross r plus to r plus. 10th one, a equals to r, the set of real numbers, and a star b equals to a plus b plus ab, where addition is usual addition and multiplication is usual multiplication. Now this will be a binary operation because the result will always be a real number. Output will always be a real number, and that will give you the codomain's element. So f is a function or a binary operation from R cross R to R. Now two more examples to understand it completely. 11th, a equals to q, the set of rational numbers, and a star b equals to a by b. Comment your answer below whether this will be a binary operation or not. Let us show you how it will be and it will not be. First of all, it will not be a binary operation as the base can be 0, and if the base is 0, the term is not defined, and hence there will be no map, and hence there will be no binary function, binary operation. Now a equals to q positive, the set of positive rational numbers, it means it does not have 0 in it, and then the same operation a star b equals to a by b. This will be a binary operation as the output will always be a rational number, and hence f from q plus cross q plus to q plus will be a binary operation. So in this video we learned about binary operations definition and 12 examples we discussed to understand it more clearly. In the next video we will be learning about the properties of binary operations and how they can be used for multiple questions. Thank you, and you can be a member of our social club and watch 550 plus videos on our YouTube channel and get a complete study material for the mathematics competitive exam from our WhatsApp group.